These are a few images from the internet about volume of the solid generated by revolution. As you see, if you are given a curve of this form and it's generating about the x-axis, it will make or generate a solid of this form, which looks like a bell shape. Another example of if we had, as I said earlier in the lesson, a rectangle and you are revolving it again about the x-axis, it will generate a solid which looks like a cylinder. As well as if we had this line or array, a straight line or array generated, it generates a cone. So this is when you are revolving anything about the x-axis, and the formula that we will be using, volume is equal to pi from a to b y squared dx, or it could be f of x squared dx. So we're going to look at this example, and this one is from 2009, and as you see it's worth 3 marks. Okay, the question says the diagram is given to you, and as you see the function that we were working on is y equals sec x, and you are given the terminals, the boundaries from x equal pi on 3 and x equal minus pi on the 3, and it's bounded by the x-axis. And now the solid, the volume that you have to find, is rotated about the x-axis. So this definitely we will be using the formula v equal pi from a to b y squared dx. There's not much to be changed here, but as you see the curve is symmetrical about the y-axis, so instead of making the terminals from minus pi on 3 to pi on 3, we can actually just do it from 0 to pi on 3 and times that by 2, and it will give us the whole thing. Okay, in the next slide we'll see how it works. So a couple of things you need to know, that the integration of sec squared dx is tan x plus c, and that's given to you in the HSC paper. Alright, so we have from the volume that we're calculating, but I use a black pen, it's a 2 pi from 0 to pi on 3 sec squared dx. I already explained why we put the 2 there, because instead of doing it from minus pi on 3 to pi on 3, we're doing it from 0 to pi on 3 and doubling the amount. Okay, so that will give us 2 pi. As I said, the integration of sec square x is tan x, and of course it's from 0 to pi on 3, and it's pretty straightforward. Just substitute, get 2 pi tan of pi on 3 minus, always put a bracket, tan 0 close bracket. And continuing from the previous page, we end up with 2 pi bracket square root 3 minus 0. Tan of 60 is square root 3, tan of 0 is 0, and that gives you 2 square root 3 pi cubic units as we are calculating the volume. Thank you.